Good morning. My name is V. Selva, Assistant Professor, Mechanical Engineering in Kongonadu College of Engineering and Technology. Now I talk about the subject of Dynamics of Machines, the Unit 4, Forced Vibrations. Forced, forced vibrations. Then what is mean by vibrations? Free vibrations, forced vibration, tamped vibration, untamped vibrations. Then free vibrations, vibration that occur in the absence of friction and external force after initial release the body. For example, simple pendulums. Then forced vibrations, when the repeated force continuously act on the system, the vibrations are said to be forced vibration. For example, pendulum in a clock. Now I talk about the forced vibrations. Vibration can be created by any following method of forcings: step input forcing, harmonic forcing, periodic forcings. Example for forced vibrations: vibration of floor caused by running of heavy machineries. The second one, vibration of car when running in on uneven road surfaces. Vibration in reciprocating engines due periodic reciprocating of pistons. Then types of forced vibrations. Periodic forcing functions, that is the harmonics and the non-harmonics. Impulse type of forcing functions resulting in transient vibrations. Third one, random forcing functions, that is the earthquakes and acoustic excitations fall under these categories. Then forced by damped vibrations, given the force, that is the F is equal to F naught sin omega t, the downward motions. Inertia force, the M into X offered, damping force Cx offered portions, swing force S into X offered portions. So the equation is solved by this complementary function and a particular integral. X is equal to Cf, that is the complementary function, plus Pi, particular integrals. Complementary functions x into e power minus theta omega n t sin omega d t plus pi 1. The particular integral is equal to f naught divided by the root of s minus m into omega squared whole square plus c w whole square sin omega t minus pi. So the actual practice value given by complementary function is so small and easily neglected. So the amplitude A is equal to f naught divided by root of s minus m into omega squared whole square plus c omega whole squares. The next one, magnification factor. It is the ratio of steady state amplitude to the zero frequency deflections. The next one, vibration isolations. Vibrations produced in a machine is transmitted to the foundation upon which it is mounted. These vibrations produce undesirable effect and should be avoided. This vibration should be isolated using springs and dampers. The concept of transmissibility comes into role to determine the amount of vibration that are transmitted to the foundation and isolated the same. Isolation forces. Vibrations produced in unbalanced machines should be isolated from the foundation so that the adjoining structure is not set into vibrations. This type of isolation is known as the forced isolation. For example, an item of equipment such as computer monitor, which is not of itself a vibration generator, may receive objectionable vibration from another sources. To overcome these vibrations, force isolation is to be done. Isolation of motions. The unbalanced machines are isolated from their foundations so that there should not be any damage either to the machines or the foundations. This type of isolation is known as the motion isolations. The type of isolations. If the transmission of force is prevented or reduced, then the effectiveness of isolation is known as the force isolations. The effectiveness of isolation measured in terms of motion transmitted is called as motion isolations. The lesser the force or motion transmitted, the greater will be the isolations. Isolating materials. What are the materials used in the isolations? Rubber band or slab, filter, cork, metallic spring washers. The next one, transferabilities. The transferability means the ratio of force transmitted to the force applied is known as the transferabilities. Force transferability means transmittality is the ratio of the force transmitted to the foundation to that impressed upon the systems. Then motion transferability or amplitude transferability. Motion or amplitude transferability is the amplitude, absolute amplitude of the mass to the amplitude of base extensions. Motion transferability or amplitude transferability. The amplitude transferability is defined as the ratio of absolute amplitude of mass to the base extrusion amplitude. Thank you.